All right, so we already had the PS4 and PS5 lesson in class on the triangle similarity criteria and then how to prove triangles are similar. So now this is kind of just a bit of a recap. So we know that two triangles are going to be similar if and only if all the corresponding angles are congruent and if the ratios of all the corresponding sides are in that same proportion. Okay, so that's something we've already covered. But sometimes it can be difficult to identify which side goes with which side. So in similar triangles, the sides facing the equal angles are always in the same ratio. So what that means is 7 is opposite, let's say, angle 1. And so you come over here, A is opposite angle 1. So we know that 7 is corresponding with A. A is opposite angle 2. Sorry, 8 is opposite angle 2. 6.4 is opposite angle 2. So we know 8 corresponds with 6.4. 6 is opposite 3. B is opposite 3. So we have this ratio. And you can see that we have this known ratio. That's the one that's like we know both parts. And so when we find these unknown lengths, we're going to start with that ratio. Let's say to find A, and we'll write the proportion 8 is to 6.4 as 7 is to A. We cross multiply and divide. We find our cross products. And in this case, I'm going to just skip a little bit of that algebra and write what A is. A is 5.6. Okay, so you solve for B. Right? Write the ratio. Use the given ratio and the ratio with the unknown length and solve for B. Okay, this next set of examples is just saying if you know that two triangles are similar and one triangle has the ratios 4 to 8 to 10, which of these following triangles is similar to the given one? Well, we know that two triangles are similar if the ratios of all their corresponding sides are equal. So we just write the ratios. Let's say, notice 4, 8, 10 is least to greatest, 2, 4, 5 is least to greatest. So we can compare 4 to 2, 8 to 4, 10 to 5, and we say, are all these ratios equal? Well, yeah, 4 divided by 2, 8 divided by 4, 10 divided by 5. Those are all equal to 2. So we know that DEF is similar to triangle ABC. Okay, the next one, again, this one is pretty easy. We can see that, the first one is pretty easy. All we had to do is double these lengths to get those. Well, now we have 6, 12, 15, 4, 8, 10. Are these two triangles similar? So again, we just compare ratios. 4 is to 6, as 8 is to 12, as 10 is to 15. Now all we have to decide is, are these ratios equal? And we could do it a couple different ways. We could reduce these and see what fraction they all reduce to. Do they all reduce to the same? We can check if cross products are equal, right? Is 6 times 8 the same as 4 times 12? If you know your math facts, this might be the easiest way. Yeah, and so that's both 48. And then here, is 12 times 15, 12 times 10, which is 120, the same as 8 times 15? And it is. So these ratios are equal, so we know that these two triangles are proportionate. All right, go ahead and just try C on your own. Determine if 4, 8, 10 is in the same ratio as 6, 10, 12. All right, so as we mentioned in class, there's 3 ways to determine if two triangles are similar, and that's the angle-angle similarity postulate, the side-angle-side similarity, and the side-side-side similarity. And so this first one is called angle-angle. This says if two angles of one triangle are congruent to two angles of another triangle, then we know those two triangles are similar. So the idea is we can draw a triangle, let's say ABC, triangle DEF, so we'll label this A, B, C, D, E, F. So if we know two triangles, let's say A and D are congruent, and maybe we know C and F are congruent. If that's all we're given, then we know that triangle ABC is similar to triangle DEF. All right, the next theorem is the side angle side similarity. So SAS. We just put the little similar sign so we know we're not doing the one for congruence. Okay, and this time it says if two pairs of sides are in the same proportion and their included angles are congruent, then we know the two triangles are similar. Okay, so again, we can draw a couple triangles. Call it ABC, DEF. Okay, this time we're saying that the ratio of AB to DE, maybe that's equal to the ratio of BC to EF. That's probably a little confusing to look at. And then we have this included angle that's congruent. Well, if that's true, then triangle ABC is congruent to triangle, or similar to triangle DEF. All right, and the last one is side, side, side. This time, if all three pairs of sides are in the same proportion, then the two triangles are similar. Okay, I'll just use this same diagram from above and we'll write the proportions. So the idea is if AB to DE, that ratio is equal to BC to EF, erase that, and AC is equal to DF. So if the ratio of all three sides are in proportion, then we know the two triangles are similar. All right, let's go to the next page, see a few examples. So we're just checking, are the two triangles similar, and if they are, by what criteria? So the first one, well, we can see that this is 150, this is 130. So the supplement of this is also 50. Okay, what that tells us is, well, I guess it tells us that 50 is congruent to 50, and both triangles share angle A. So by angle, we know that those two triangles are similar. Okay, in the next example, we can see we've got vertical angles, so we have at least one angle. And then we have 9 is to 8, or maybe as 12 is to what? Well, there's nothing else, there's no other given information, so triangles are not similar. All right, so go ahead and just check out these two, determine if they're similar and by what criteria, and then down below, you're going to write and solve a proportion to solve for x, to find the value of x. Okay, so pause the video, do those three, and then on the next page, we're going to start some proofs. All right, so we did a few of these again in class. It's more just about kind of learning the format of it. We're going to prove that the two triangles are similar, given that A and D have the same measure. Okay, so we first labeled our given information. Now we come over to the diagram. We label any other known information. In this case, we have vertical angles. Okay, so pretty quick, we can see the two triangles are similar by angle. So this is how we're going to write it. Angle A is congruent to angle D, and that's given. Angle CBD is congruent to angle EBA. That's that vertical angle theorem. So therefore, triangle ABE is similar to triangle DBC. In this case, we say by angle similarity. All right, next. We'll do one more where we prove triangles similar, and then we're going to prove some parts and some ratios. All right, so this time ADC and BEA are right angles. So ABC, so that's, I'm sorry, ADC is this angle, that's a right angle, and BEA is a right angle. Prove that triangles ADC, let's see, ADC, that's that one, and AEB, that's this one, are similar. Well, they overlap, and you can tell right here, both triangles share A. So we can come over here and we can see for a fact that A is included in both. Okay, so now we know, looking at, say, at ADC, that we have this green angle and we have the red one. And then in AEB, we have the green angle and we have a red one. So again, by angle, we know the two triangles are similar. All right, write this first statement in the first one. You're going to have to write it kind of small. Angle ADC and angle BEA are right angles. Okay, now we can say that angle ADC is congruent to angle BEA. And how do we know that these two angles are congruent? Because all right angles are congruent. So we'll just say that. Right angles are congruent. It's kind of by the definition of right angle. Maybe that would have been the better reason, but it's the same idea. All right angles are congruent. Okay, next we have this shared angle. Angle A is congruent to itself. Okay, and that's because of the reflexive property of congruence. And so now we can say, therefore, triangle ADC is similar to triangle AEB by angle similarity. All right, we got two more proofs. These two just are slightly different. This time we're going to prove a proportion. This one we're proving a cross product. Try and make it quick. All right, so again, we look at our given information. SR is parallel to TG. And in this case, since we have parallel lines, we know that alternate interior angles are congruent. And we can name both pairs. All right, so we have another alternate interior angle, or a pair of alternate interior angles there. So we know by angle, these two triangles are, I'm sorry, move it down a bit. We know that by angle, these two triangles are similar. Okay, but that's not exactly what we're trying to prove. We're trying to prove that the ratios of the corresponding sides are equal. But first, let's prove the similar part. And so we're going to say SR is parallel to TG, and that's given. And now we know that angle S is congruent to angle G by the alternate interior angle theorem. We'll try to abbreviate it that way. Alternate interior angle theorem. And we also know that angle R is congruent to angle T. Again, alternate interior angle theorem. Okay, so now we know that the two triangles are similar. So triangle RSQ is similar to, we got to make sure we get this in the right order. So R, so we went to 2 to 1 to 0. So TGQ. Okay, they're similar by angle. But now, knowing that these two triangles are similar, then it must be true that the ratios of their corresponding sides are equal. Why? Because that's the definition of similarity. So, therefore, QR is to QT as QS is to QG. Why? Definition of similar triangles. This we'll try to abbreviate. All right, we're at 15 minutes. One more proof. This time we're proving cross products. Given that angle G is congruent to HI. Oh, I didn't have my I in there. There's I. HIJ. And so we're proving the cross product HI times HF equals HG times HJ. And one thing to recognize is we've got the large triangle and we've got the small triangle. Both the large and the small share angle H. Okay, so again, we're going to use angle, but this time we're proving cross products. Okay, so angle G is congruent to angle HIJ. That's given. Angle H is congruent to itself. That's the reflexive property. Okay, therefore, we know that these two triangles are similar. HIJ is similar to, okay, let's make sure we get it in the right order. HIJ, well, we better start with our H. Notice we went from H to the angle that's marked, so we'll go from the H to the angle that's marked, HGF. Okay, and that's angle. Okay, so now basically this proof is just one additional step from the proof before. Now we know that the ratios of their corresponding sides are equal. So HI is to HG. HI is to HG as HJ is to HF. Again, that's definition of similar triangles. Okay, so if this proportion is true, then it must be true that their cross products are equal. HI times HF is equal to HG times HJ, which is what we're trying to prove. So therefore, HI times HF is equal to HG times HJ. By what reason? We're just going to say that cross products are equal. Okay. All right. 17 minutes and 43 seconds. See you in class.